Okay, till last lecture we all had discussed about the dominant and recessive epistasis, right? I had
Yes,
given
ma'am.
you one home assignment also. I hope you all have solved that particular home assignment. Now, today we will be talking about the double dominant epistasis. Double dominant. Now, in the case of the dominant epistasis, children, what we would have observed, we observed in the case of the dominant epistasis, if the dominant gene is present, even a single allele of the dominant gene is present, it does not allow hypostat to express itself, right? So in the previous case we all have seen that one gene, capital A, was the dominant and it was hypostat to the other gene. But in the case of the double dominant, if both the gene are present, so that time they are going to express a single trait. So until dominant epistasis and recessive epistasis, we were observing three types of traits. In the double dominant, we are going to observe only one trait. In the case of the double recessive also, we are going to observe only two traits. Okay. Now, in the case of the double dominant epistasis, we all have observed that the normal Mendelian ratio 9 as to 3 as to 3 as to 1, it was modified as 12 as to 3 as to 1. Is it? Right, so now here what is going to be happen here, the ratio will be 15 as to 1. Now how it happens in the case of the double dominant epistasis, even a single, both the genes are dominant, equally dominant, so there is no hypostat here. Okay, so even A is present in the dominant form or B allele is present in the dominant form, the dominant trait is going to be expressed. Now how it happens, we'll see with the help of this dihybrid cross chart. So here the feathered chunk chicken, how they look like, I will show you. These are the feathered shell and this is unfeathered chicken. Okay, so let us go to our example. So one feather shank chicken, it was having the genotype as capital A, capital A, capital B, capital B. When it was crossed with the unfeathered shank chicken, that is small a, small b, small b. So the cross, after the cross, they got the feather shank because it was the dominant trait, and they made the chart. Now we all are very much expert to make the chart. That's why I'm taking the lecture on PowerPoint directly. So it is observed whether capital A, capital B, whatever is present, the chicken will show the trait as the feather shank only. Here you can see feather shank, feather shank, feather shank. Now here capital A and capital B is present. But in the second row, here you will observe only capital A, but small b is present. Right?
Yes, ma'am.
This case you observe here capital B is absent, here also capital B is absent. Now if you will observe here capital A is absent, but everywhere we all will observe that the feather shank is there, even if a single dominant gene is present. But in only and only one case where capital A and capital B both are not present, unfeathered shank chicken is observed. So here the highest probability of the dominant character has been observed. So always you will find that in the case of the double dominant epistasis, that trait is very wild type, or you can say it is very much present into the population. Understood? So you will not get so much of this type of chicken, right? You will observe always this type of chicken very much. That is the feather shine. Now double recessive, now what will happen in the case of the double recessive? In the case of the double recessive, you will observe that even one case here hypostat is there, and one case you will observe capital A and capital B. If it is both are present, so that particular time you will observe the dominant trait, but only one type of dominant thing will not helpful. Example is this. Here, capital B is absent, so the person is deaf and mute. Okay, and this case, here capital A is absent, deaf and mute. So this is called as a double recessive. So for this study, one cross is done into the deaf and mute, and we all know we had seen into the last to last lecture that normal hearing is the dominant trait, right? So capital A and capital B, if both are present, so you will observe that normal hearing. Here also you can see normal hearing. Now here this individual is lacking capital B, capital A is present but capital B is absent, so the person will be the deaf and mute. Here also normal hearing will be observed, capital A and B present. Here capital A and B is present, capital A and B is present. Here capital A is absent but capital B is present into the double allele form, but still the person is deaf and mute. Here also, now here capital A and capital B is present. So if we will count the ratio, so we will observe 9:7 ratio. So
मैम
yes,
मैम स्क्रीन पर तो 15:1 वाला ही दिखा रहा है, फेदर शेक वाला ही है.
this ratio is not shown on the screen. Just a minute.
यस मैम.
Just a minute.
यस मैम, आप शो हुआ.
Now it is shown.
यस मैम.
So in the case of the double recessive, deaf and mute was crossed with the deaf and mute, but in this first parent you will observe capital A is lacking. Okay, and in this parent you will observe capital B is lacking. Okay, so what will be the gamete? Small a, capital B. So small a and capital B, here capital A and small b. So when the crossing is done, so this parent give capital A, small a, capital B, small b. So the individual, or you can say the resulting offspring F1 was noted as having the normal hearing. When this normal hearing individual crossed, so after that normal dihybrid cross table which we usually make. Okay, so it is observed the individual, those who all were having the capital A, or you can say the first dominant gene as well as the second dominant gene. I told you in the case of the double dominant and double recessive, there is no hypostat. Okay, there is only epistatic relationship or epistatic interaction. So if both the dominant gene are present, that time only the dominant trait will be observed. Even if a single dominant trait is lacking, as you all can see in this case, capital A, small a is present, but capital B is not there, so the person will be the deaf and mute. Here also you will observe. Okay, here in this case, capital B is present, but capital A is missing. The person is the deaf and mute. Understood? So, in the case of the dominant epistasis, we have learned even if a single dominant gene is present, the dominant trait will be observed, and the ratio was 15:1. In the case of the double recessive, both the dominant allele are present, that time only the dominant trait can be observed. In the absence of a single dominant trait, the person will acquire, or you can say the organism will acquire the recessive trait. So here the normal 9:3:3:1 ratio will be changed, and you will observe the 7% they are acquiring the recessive trait. So the ratio will be 9 dominant as to the 7 recessive. Understood? As we have seen in the case of the double dominant, the ratio was 15:1. So let us revise the new ratios designed with the epistasis. In the normal ratio, Mendelian ratio is 9:3:3:1. But in the case of normal, or you can say the dominant epistasis, single dominant I'm talking about, in the case of the dominant epistasis, our ratio will be 12:3:1. In the case of the recessive epistasis, the ratio, what would be the ratio? The ratio will be 9s to 3s to 7. And in the case of the double dominant, the ratio, sorry, 9s to 3s to 4. In the case of the recessive epistasis, I repeat, in the case of the recessive epistasis, the ratio will be 9s to 3s to 4. In the case of the double dominant, the ratio, now I told you in the case of the dominant epistasis and recessive epistasis, three traits were observed. So three ratio formed, like in the case of the dominant epistasis, the ratio formed was 12s to 3s to 1, and in the case of the recessive epistasis, the new ratio formed was 9s to 3s to 4, because there were three traits. But in the case of the double dominant epistasis and in the case of the double recessive epistasis, the two traits are only been observed, so the ratio modified in the case of the double dominant will be the 15s to 1, and in the case of the double recessive, the ratio will be 9s to 7. So this is all about the epistasis. If you all have any doubt, definitely you all can ask me. Any doubt, student?
No, ma'am.
Shall we go ahead?
Yes, ma'am.